Hello again, magical creatures. We are going to make changes to our file today, specifically for 3D printing. So for laser cutting, which is subtractive, we have something that's cutting away at a solid piece of material. And as it does it, the width of that material curve, the width of the cutter, cuts away a little bit too much. And there's some sort of compensation that we have to do. And we focused on the holes and the width and the height here. And on 3D printing, we have a different effect, and it's actually the opposite. And I'm just gonna call it oozing or shrinking. So let us sort of consider the same shape, and I've drawn these little spots here. Basically, all of the corners and the holes are subject to either shrinkage or oozing. And let me show you what I mean real quick. I have these 3D parts, 3D printed parts, which is our bracket. And you should notice that the holes on one are bigger than the holes on the other. And this one on the left here is the one that is true to form. It's 3 millimeters, it's 10 wide. And you can tell, maybe a little bit more clearly by looking at the back, that like on this corner here, there's a little kind of pop-out part. And on this corner here, there's a little pop-out part. And then over here, there's one. Just a little bit. It's very subtle. And the question is does that make enough of a difference to affect things? And for just like a regular part like this, where there's no absolute fitting required, on the outside dimensions, you're not trying to fit something in edge to edge where it snaps into place. Probably doesn't matter. But eventually, very quickly actually, we're going to get to things where pieces snap into place. And that little tiny bump will make a huge difference. And then of course, we've already talked about the holes. This hole's supposed to be 3 millimeters, and it's not. It is, boop, 2.47. 2.47. It is too small. These shrink. So what happens is, and so what you do is you find the shrinkage for the holes, which there's a rule of thumb that we can use for 3D printers. We got roughly at 3 now. You see that? So the compensation that I've already made basically works. Let's do it one more time. Let's do it here. I'm using a rule of thumb that we'll learn today. So let's talk a little bit about how it's happening. It's basically because 3D printers aren't all that magical. They are just glue guns. So how does a glue gun work? Glue gun has this nozzle, makes the plastic inside the tube hot, and then some pressure. We'll use the handle. There's a motor that does this. It starts to squeeze out some material, and then that material gets laid in a bead across the surface. And humans sort of do things fluidly, right? But robots kind of don't. Robots kind of do this thing where they go, notice that corner has a little bit of overgrouping because there is oozing happening, right? This plastic is this fluid substance. And if you stop, it builds up. And so just because that little stopping part that the machine is doing causes the corners to overflow just a little bit. And the other thing that happens with plastic, which I don't think we'll be able to do in a way that we can see today, but as it dries, it'll shrink. It's hot and it's expanded, then it cools down and it contracts. And when you have it in a circle like this, it sort of contracts more or less evenly around the diameter, and then the hole gets smaller as a result. So holes pretty much always wind up a little smaller, and corners almost always wind up having just a little bit of oozing, goopage over there. How do we account for this? Well, if we look at the tip of this thing here, the nozzle, which it's not going to want to focus on because why would it ever? We can measure this. This nozzle width is, some diameter. We'll just give it a try. It's 1.5. And the question is, if we measure the shrinkage or the oozing, look at that. It's about 1.5. And so the rule of thumb that I use that works basically every time, is for diameters of circles to expand the circle, the diameter by the width of the nozzle. Different 3D printers have different nozzle widths. My friend who made this one for me, his 3D printer has a 0.6 millimeter nozzle. So I just went in and used our kerf measurement and said plus 0.6 millimeters. Did it work though, right? It did. Oh, that's the wrong side. I forgot how to, oh. And it did. Right at 3, right? So 0.6 millimeters wider because the nozzle width. And then I did the same thing for the corner. There's a thing called a fillet, which we'll do today very quickly, which rounds corners, makes really nice inside edges. And then for the inside corner is a little special. The inside corner, a fillet wouldn't work because what happens is that it goes in and it oozes towards the inside of the gap. So we actually have to cut away a little bit in order to account for the overflow so that the inside corner is a little sharper. So let's just go ahead, pop off the computer world and get that done, okay? We're back in computer world. And we are in our my second bracket, which we modified that part studio to create the laser output. And rather than editing this directly, we will right click on this tab at the bottom here and duplicate it. Boop. And we will rename it to be 3D printer. And we have already done all the setup that we need to, I believe. We have a width, a height, a diameter, thickness, and a curve. We'll go ahead and rename this to be clear. So I right click on it, go to edit. The name is here, and we'll call it nozzle because of the nozzle of the glue gun. The 3D printer has one of those. And we know that it is 0.6 because we talked to our friend and he told us. A lot of them are 0.4, but there's a shift in the 3D printing world to go to 0.6 for a lot of good reasons. So we're sort of on the bleeding edge. We have a whole 0.2 millimeters, and all we have to do is look at this little guy here. We can say we'll go double check the sketch and see what we have applied. So these holes are going to be the diameter plus the nozzle, which is what we want. Those holes are going to be bigger than the file will be bigger. We want to take care of these corners, and we want to do that special thing on the inside corner here that I talked about. So the drawing here is just fine. And for 3D printed files, we actually use the extrude. So we just sort of roll over that spot and hit boop. But not the circles, right? We don't want the circles. We want the shape itself. We'll go up to here at the top, boop. And we want a 2 millimeter part. And then we want to make sure it's solid. And we hit OK. So the only thing left now to do is to learn to use fillets. And there's a lot of, quote, operations that you can do. So this extrude was an operation to the drawing. And these other surfaces and edges you can do more operations to. And what we're going to do is do an operation to this edge here and see what happens. So going up to the top, there's most of the common ones here are listed, and fillet is one of my favorites. And maybe it's fillet. I don't know. But it just sounds too much like a fish. So I say fillet. And I hit that. Notice that corner has changed. Let's look at it from this other angle here. See how it's moved inward and the arrow tells you which way it's going? And the radius there is 0.6 by some reason. But you can go all these different distances. You get these rounded corners. So if you want that that nice apple corner, I want to say is roughly somewhere between 4 millimeters and 6 millimeters. And it's just you can create these nice soft edges where the corners aren't pokey. But in this case, we just want to use it to get rid of some of that oozing that happens when the robot stops right there for just a second and starts its path again. So all we have to do is just click on that value, type in nozzle. And that should compensate for all of it. Now there's all these other corners. So we just go and select them all. Boop, boop, boop. And get this guy here. Boop. Hit the fillet. We'll do it again. Now, I haven't really told you how to edit things, and I'm going to now. So all of them are done, but now we have 2 fillets, and we could have done this in one. So let's undo that. We made the 1 fillet, but it only affected the 1 corner. Wouldn't it be nice if we could go back and change that? And you can. You go back to this layer, and you can do this for all the layers. If you want to edit a sketch, you can just double-click the sketch and edit it. We're going to double-click this fillet. Boop, boop. And over here where it says edges to extrude, see how when I roll over it, that blue spot up in that dialog on the right, the little line that we had selected highlights? All we got to do is, as long as that's highlighted blue, we can go and do it again. And again. And again. Boop. Boop. So now all of those corners, the outside corners, are adjusted for the nozzle diameter, and the ooze should be compensated for. What do we do about this inside one though? Well, a real common technique is called a dog bone fillet, and I don't know that Onshape has one, but it's pretty easy to mimic. And all we have to do is create a hole just right at this point right here. So we select a point, so our sketch is visible. If it wasn't visible, we wouldn't have that point. Oh, we'd have the point of the surface, I guess we could use. Select that point right in the inside corner, and then we go up to the hole tool. Remember the old hole tool that we sort of used and then abandoned? Well, it's back, and it's going to be handy for us. So we make a hole. We just make that hole the nozzle diameter. We make it all the way through. And that is the first part of our dog bone fillet. The other thing we want to do is get rid of these corner edges, because we don't want any oozing to come back. Right here are those sharp edges right there. It's kind of hard to see because of the angle, but we don't want any oozing to happen there, so we want to get rid of those. And we could go ahead and add another fillet, another operation, or what we could do is reorder this. So this hole, we could do the hole before the fillet, just clicking and dragging. Now the hole exists before the fillet happens, and now I can go open this fillet, and this is highlighted blue, and I can just select these edges. So we're doing a little revisionist history. So now, if you look really closely, let's get a good angle on this for you. Now, that's a nice, smooth, fluid thing with no sharp angles. And that's it. That is the exact part that I created. And as you saw before, the measurements are more accurate. The outside edge corners don't have that bump out. They're right exactly at 10 millimeters, and the inside is almost exactly at 3 millimeters, which is what we want, because the screws we have fit exactly 3 millimeter holes. And that is how you do it, folks. That at this point, you would go to the bottom tab here. You would say export. You would say the format is STL. That's pretty much the standard format for a 3D printer and whatever software they're using. And then you want binary. We made ours in millimeters, and I pretty much just leave it defaulted at fine, because it is so fine when you do that. And then we just hit export, and then it saves that STL file, and you could take it to a library to get printed. You could take it to a friend. You could buy a 3D printer, and you're all set to go. Well, that's it, and have a great life if I don't see you again.